You see a dot of light moving through Sagittarius, magnitude 18, 4.5 billion kilometers out. July 1st, 2025, the Atlas telescope in Chile flags it. Designation A11PL3Z. Within hours, they run the numbers backward. The orbit bends wrong, not an ellipse. A hyperbola. This thing punched into our solar system from another star, and it is not staying. 3 days later, the Minor Planet Center makes it official. 3I Atlas, the third interstellar object ever confirmed. 1I Oumuamua flew through in 2017. 2I Borisov showed up in 2019, now this. But from the moment they pinned down its trajectory, something felt off. The numbers did not add up like a random visitor. They added up like a message. It is the best way to support our work. Also, comment from which city you are hearing this from. This script is researched and factual using sources from NASA's official science pages, published July through October 2025. Avi Loeb's peer-reviewed Medium posts from August through October 2025, published through Harvard's Institute for Theory and Computation, the James Webb Space Telescope NIR spec data. Released August 25th, 2025 in Archive, preprint 2508.18209, Wikipedia's 3I Atlas page, last updated October 23rd, 2025 at 1400 UTC, the Very Large Telescope Spectroscopy. Published August 21st, 2025, ESA's official FAQ, updated October 15th, 2025, and the International Asteroid Warning Network editorial notice from October 21st, 2025, accessible through the Minor Planet Center. Now back to the information. The comet moves at 61 kilometers per second relative to the Sun. That is 137,000 miles per hour. Faster than Oumuamua, faster than Borisov, hyperbolic excess velocity, 57 kilometers per second. The escape velocity from the solar system at its discovery distance is around 42 kilometers per second. It has 26% more speed than it needs to leave forever. That extra velocity tells you one thing. It came from somewhere with momentum to spare. Yi Guo and collaborators publish a dynamical study tracing 3I Atlas backward through the galaxy, kinematic reconstruction, positions and velocities of nearby stars over the past 10 million years. The analysis shows 3I Atlas may have passed within 1 parsec of 25 known stars, 3.3 light years, close encounters, gravitational interactions, possible origin points. The parent star is unknown, but the properties can be inferred. The composition and dynamical membership in the galactic disk. If it originated from the Milky Way's thick disk, the parent star is old. Low metallicity, heavy element abundance at least 40% of solar, the thick disk is ancient. Stars there formed 7 billion years ago or older, before the Sun, before the solar system. 3. Atlas could be twice as old as Earth, a relic from when the galaxy was young. It had been sliding past the galactic center's star fields for weeks. Dense background, easy to miss. NASA's test spacecraft, the Transiting Exoplanet Survey satellite, had captured it even earlier. May 7th, 2025. The comet was 6.4 astronomical units from the Sun, farther than Jupiter. Already active, already outgassing. The pre-discovery observations pushed the detection window back 2 months before official discovery. It was visible, it was moving, it was brightening. The coma was growing. From 13,000 kilometers on June 21st to 19,000 kilometers by early July. Expansion rate consistent with increasing solar heating. By the time they spot the coma on July 7th, it is official. Not an asteroid, a comet, active, outgassing. A cloud of gas and ice dust 400,000 kilometers wide in the infrared. 56,000 kilometers visible in optical, the nucleus hidden inside. Nucleus diameter between 0.32 and 5.6 kilometers, most likely under 1 kilometer, but the coma is bright, too bright. Reflected sunlight does not explain it all. Something inside is glowing, something is releasing energy. The Gran Telescopio Canarias, 10.4 meter telescope in the Canary Islands, images it July 2nd. High resolution. The coma appears slightly elliptical, 26,400 by 24,700 kilometers, twice Earth's diameter. The asymmetry is real. Not instrumental, not atmospheric. The coma is elongated. The dust distribution is not uniform. Something about the outgassing pattern or rotation state creates the shape. NIR spec integral field unit, spatially resolved imaging spectroscopy. 3 arcseconds by 3 arcseconds. 0.1 arcsecond resolution. The chemistry lands like a hammer. Carbon dioxide dominates, 87% by mass, water 4%, carbon monoxide 9%, traces of carbonyl sulfide. The carbon dioxide to water ratio is 7.6, 4.5 sigma above the trend for long period comets. Excluding the outlier C 2016R2, this is the highest carbon dioxide ratio ever measured in a comet. Solar system comets run 80% water. 3. Atlas runs 4% water. Backward, dry, cold. Obscuration by dust and other gases makes exact quantification difficult, but the presence confirms deep composition. Isotope ratios tell you formation conditions, temperature, radiation environment, shock processing. The carbon-13 detection adds another layer. Not just what molecules exist, but which isotopes. Stellar nucleosynthesis fingerprints. This comet formed in specific conditions, possibly beyond the carbon dioxide frost line in its parent protoplanetary disk, possibly in a thick disk stellar environment 7 billion years old. Low metallicity parent star, heavy element abundance 40% of solar, the chemistry matches old cold formation far from a dim star. The imaging spectrophotometry runs 0.75 to 5.0 micrometers. Carbon dioxide gas production, 9.4 times 10 to the 26th molecules per second. That translates to 70 kilograms per second. Water production rate, upper limit, 1.5 times 10 to the 26th molecules per second. Carbon monoxide, upper limit, 2.8 times 10 to the 26th molecules per second. The carbon dioxide cloud extends 348,000 kilometers. 3. Arc minute radius clearly resolved. The water cloud barely registers. Assuming 0.04 albedo for the nucleus, the radius calculates to 23 kilometers, but Hubble constrains it to 2.8 kilometers maximum. That means 99% of the Sphere-X continuum flux comes from coma dust, not the nucleus. This is not how comets behave in our neighborhood. The dust dominates, the nucleus hides. Not nickel-bound disilicates. Atomic nickel vapor, the Swift Observatory ultraviolet observations, July 30th and August 1st. Hydroxide ions detected, water vapor proxy. Estimated water production rate 40 kilograms per second at 3.51 astronomical units. But this is dwarfed by carbon dioxide. The ratio stays extreme. September 7th, the James Clerk Maxwell Telescope measures hydrogen cyanide production, 1.5 times 10 to the 25th molecules per second. September 14th, that rate triples. 4.5 times 10 to the 25th molecules per second, 2 kilograms of hydrogen cyanide per second. The comet is accelerating its outgassing as it falls toward the sun. Webb also detected carbonyl sulfide, OCS. 0.4, 3 kilograms per second, another sulfur-bearing molecule. The sulfur chemistry adds complexity. Comets contain sulfur, but the specific molecules and ratios constrain formation temperature and radiation processing. Narrowband at 0.3865 to 0.3885 micrometers for nickel, 0.3605 to 0.3625 micrometers for cyanide. The emissions are asymmetric. They extend both toward the sun and away from it. Sunward jet confirmed. Anti-tail. Not an optical illusion, not geometric perspective. Real gas pushing toward the star that should be pushing it away. The nickel plume reaches 600 kilometers from the nucleus. Cyanide reaches 840 kilometers. Nickel mass loss, 0.9 grams per second. Cyanide, 3.9 grams per second. Total mass loss, 150 kilograms per second. On Earth, this signature appears in one place. Industrial nickel refining. The carbonyl process, nickel tetracarbonyl. Nickel carbon monoxide 4. You heat nickel ore with carbon monoxide. Nickel carbonyl forms as a gas. You decompose it. Pure nickel precipitates out. It is how we make nickel alloys. The nickel to cyanide ratio in 3 I Atlas is orders of magnitude higher than any known comet, including 2 I Borisov. The paper from WB, Hugendam, and team published October 15th, 2025 in Archive 251.0.11779 suggests this carbonyl process happens naturally near the nucleus. They argue in situ formation of nickel tetracarbonyl. They predict nickel should concentrate near the nucleus. The images confirm it. Central nickel, diffuse cyanide, chemistry that looks like a factory. Between May 15th and September 23rd, 2025, the Minor Planet Center compiles astrometric data, 4,022 observations, 227 observatories worldwide. Richard Cloete, Peter Veers, and Avi Loeb analyze the trajectory. They compare observed positions to predicted positions based on gravity alone, the residuals in right ascension and declination, the deviations from pure gravitational motion. Upper limit, 0.028 arcseconds. Non-gravitational acceleration, less than 15 meters per day squared. That is tiny, almost nothing. Webb measured mass loss, 150 kilograms per second. Outflow velocity, 440 meters per second. That much material at that speed should push the nucleus, should bend the trajectory. It does not. The path stays gravitational. The conclusion is inescapable. The nucleus is too massive to move. Momentum conservation. Force equals mass times acceleration. If acceleration is near zero and force is known mass must be enormous. At solid comet density around 1 gram per cubic centimeter, the diameter must exceed 5 kilometers. 3 miles. That is the lower bound. Not the estimate, the minimum. It cannot be smaller. Hubble's upper limit was 5.6 kilometers. SphereX suggested 23 kilometers if all the brightness came from the nucleus. The truth sits somewhere between, but even the minimum is anomalous. Oumuamua was 0.1 kilometers. Borisov was 0.6 kilometers. 3I Atlas is 5 kilometers minimum. That is 3 to 5 orders of magnitude more massive. 1,000 to 100,000 times heavier. Large objects are rare. For every 5-kilometer object, there should be 100,000 0.1 kilometer objects. We should have detected 100,000 Oumuamuas before finding one 3I Atlas. Instead, we detected 2, Oumuamua and Borisov. Then this. The sequence is backward. The rarest object arrived third. Either our detection models are catastrophically wrong, or the population is not random, or 3I Atlas is not natural. One of those three must be true. 56,000 kilometers. Dust particles ejected at high speed. Effective radius 0.1 millimeters. Slow ejection 5 meters per second. Sluggish response to solar radiation pressure. No normal dust tail visible in white light. Radiation pressure should push small particles into a streaming tail pointing away from the sun. It does not. The tail stays symmetric, broad. The dust is heavy, or the geometry is wrong, or both. Not Borisov. Not any solar system comet. The light reflected off 3I Atlas is polarized in a way that does not match natural cometary dust. The degree of polarization sits outside known parameters. Another outlier. Inclination, 175 degrees. Retrograde. It is moving backward relative to the planets, but the key number is 5 degrees. The angle between its trajectory and the ecliptic plane. The ecliptic is the flat disk where the planets orbit. Random interstellar objects come from random directions. Isotropic distribution across the celestial sphere. The odds of arriving within 5 degrees of the ecliptic by chance are 1 in 500, 0.2%. 3I Atlas threaded that needle. Closest approach to Mars, October 3rd. 18 million miles, 29 million kilometers. Mars orbiters positioned to image it. Solar conjunction. October 21st, perihelion. October 29th, Venus flyby, November 3rd, 60 million miles. Closest to Earth, December 19th. 167 million miles. 269 million kilometers. Jupiter flyby, March 16th, 2026. 33 million miles. 54 million kilometers. Then exit. The sequence threads planetary flybys while hiding behind the sun during perihelion. The one moment it heats up maximum is the one moment Earth cannot see it. Arrival time, fine-tuned. Likelihood, 0.005%. That makes it 1 million times more massive than Oumuamua, 1,000 times more massive than Borisov. It is moving 68 kilometers per second at perihelion, faster than both prior interstellar objects. Likelihood of an object, this massive moving this fast and arriving in our inner solar system by random chance less than 0.1%. Cumulative probability across just the mass speed and trajectory under 1 in 1 million. Ohio State University, frequency 14, 20.4, 556 megahertz, the hydrogen line. Blue shifted about 10 kilometers per second toward Earth. Intensity 54 to 212 Jansky. Bandwidth 10 kilohertz. Duration 72 seconds. Astronomer Jerry Amon circles it in red ink on the printout, writes, "Wow!" The signal never repeats. Sky coordinates right, ascension 19 hours, 25 minutes, 291 degrees. Declination negative, 27 degrees. Direction Sagittarius. Near the globular cluster, M55. 8 degrees in declination. Angular distance 9 degrees. Probability that 2 random directions in the sky align within 9 degrees, 0.6%. If 3. I-Atlas transmitted the WOW signal from 600 astronomical units. The required transmitter power is 0.5 to 2 gigawatts. Output of a typical nuclear reactor on Earth. The WOW signal was blue shifted 10 kilometers per second. 3 I-Atlas approaches at 60 kilometers per second. Same order of magnitude. Wrong exact value. Maybe Doppler from internal motion. Maybe noise. Maybe coincidence. Maybe design. Avi Loeb assigns it rank 4 on the Loeb scale. The scale runs 0 to 10. 0 is definitely natural. 10 is definitely technological. Rank 4 means unusual but not conclusive. Persistent anomalies that resist conventional explanation but do not prove artificiality. The scale is quantitative. Published in peer-reviewed papers accessible through Harvard-Smithsonian Center for Astrophysics. Each anomaly gets a probability, the probabilities multiply. The cumulative likelihood determines rank. Rank 0 to 2 is mundane, natural objects with explainable variance. Rank 3 to 4 is anomalous, requires attention, warrants follow-up, not proof, but not dismissible. Rank 5 to 7 is highly anomalous, multiple independent anomalies. Natural explanations strain credibility. Rank 8 to 9 is extraordinary. Technology remains plausible alternative. Warrants active monitoring. Contact protocols. Rank 10 is definitive. Unambiguous technological signature, artificial structure, coherent signal, controlled maneuver. Nickel without iron. Low water. Extreme polarization. Wow, signal alignment. Multiply the individual probabilities. 1 in 500 times 0.005% times 0.1% times 0.6%. Cumulative likelihood below 1 in 10 quadrillion, 10 to the 16th. You can argue each anomaly separately has a natural explanation. You cannot easily argue all 8 together are coincidence, but absence of proof is not proof. Anomalous does not mean artificial. Strange does not mean designed. The burden of evidence demands more. That is why it is rank 4, not rank 8. The data permits both interpretations. Natural comet with improbable properties. Technological probe with cometary camouflage. The observations do not distinguish. November will. High-rise camera aboard Mars. Reconnaissance orbiter images it. Resolution 30 kilometers per pixel, 3 times sharper than Hubble. The camera can image objects down to 0.3 meters per pixel when aimed at the Martian surface. From the distance to 3, I-Atlas 30 kilometers per pixel is the limit. But that is enough. If the nucleus is 5 kilometers, the brightest pixel will contain nucleus photons. The brightness corrected for assumed albedo gives surface area. Surface area gives diameter. The measurement will settle whether the nucleus is truly massive or whether coma dominates. Mars Express HRSC camera also observes high-resolution stereo camera. Normally images Mars at 10 meters per pixel. At the comet distance, resolution drops, but coverage expands. ExoMars. Trace gas orbiter CASIS camera joins. Color and stereo surface imaging system. 4.6 meter per pixel on Mars. Hundreds of kilometers per pixel at the comet. Multiple instruments, multiple angles. Triangulation possible, if timing syncs. The images as of October 16th are not publicly released. NASA and ESA hold the data. Analysis ongoing. What they show will constrain nucleus size. If the brightness is a giant nucleus, the artificial hypothesis gains weight. If the brightness is coma, the natural hypothesis holds. The difference between 5 kilometers solid and 20 kilometers fluffy determines everything. Coronagraph rejection angles cannot touch it. Scattered sunlight drowns it. Earth-based optical telescopes go blind. The comet disappears for 3 weeks. Just inside Mars orbit, orbital velocity peaks, 245,000 miles per hour, 394,000 kilometers per hour, 68 kilometers per second. Solar irradiance at perihelion delivers 33 gigawatts to a 5-kilometer diameter surface. 1/3 the total power output of 94 commercial nuclear reactors in the United States. Enough energy to sublimate ice, enough energy to power a city, enough energy to run a spacecraft engine if you had one. When you burn fuel at closest approach to a massive object, you maximize kinetic energy gain. Velocity is highest. Gravitational potential energy converts efficiently. The physics is straightforward. Kinetic energy equals 1/2 mass times velocity squared. At perihelion, velocity peaks. 68 kilometers per second. Add delta V here and the kinetic energy change scales with that high velocity. The gain is maximum. Chemical rockets use it. Interplanetary probes use it. Voyager gained speed slingshotting past Jupiter. New Horizons past Jupiter. Juno past Earth. Apollo translunar injections. Every high-energy mission. You time your burn for perihelion. You get the most delta V per kilogram of propellant. The efficiency gain can be double or triple compared to burning at aphelion. If 3. I-Atlas were a mothership, and if it carried fuel, and if it wanted to change trajectory, the window is October 29th. Hidden from Earth. Maximum efficiency. Optimal conditions. Solar irradiation provides 33 gigawatts. Enough power to sublimate ice explosively or charge energy storage systems if they exist. The timing is perfect. The geometry is perfect. The energy is perfect. If you wanted to maneuver this, is when and how. Shoemaker Levy. 9 shattered passing Jupiter. Comet Atlas C 2019 Y4 disintegrated April 2020. 3 I Atlas could crack. Outgas violently, flare, eject chunks. If it is natural, that is the expected behavior. If it maneuvers, that is the unexpected behavior. We will not know until November. JUICE observes November 2nd through 25th. It has a direct view while Earth still has solar glare interference. JUICE sees the comet in its most active state fresh off perihelion. If secondary objects ejected during perihelion exist, JUICE has the best chance to spot them. If the trajectory bent, JUICE will measure it. The International Asteroid Warning Network launches a dedicated campaign November 27th through January 27th, 2026. Objective: improve astrometry for comets. Extract accurate centroids from extended coma. Exercise the capability of the observing community. Campaign target 3 I Atlas. 0.36 astronomical units. 54 million kilometers. NASA's Juno spacecraft near Jupiter. Sensors in ultraviolet, infrared, and radio. Juno could intercept if it had fuel. It does not, but it can observe. If 3 I Atlas releases probes with velocity kicks, solar tidal forces will separate their trajectories over months. By December, different objects will occupy different positions. Sky surveys will detect them if they exist. Outgassing can produce non-gravitational acceleration. Comets do this. Asymmetric jets create thrust. The rotation axis and active regions determine the direction. For 3 I Atlas, the sunward jet, already documented, could produce acceleration, measure the actual path, compare to the predicted path. Calculate the residuals. If the residuals match jet thrust, it is natural. If the residuals do not match jet geometry, it is not. The wow signal frequency. If 3 I Atlas emits radio, the power spectrum and modulation will tell you if it is thermal or coherent. Thermal emission is blackbody, random. Coherent emission is structured, patterned. An intentional signal stands out. So far, silence. Silence means nothing. You have to look. If it stays constant, that suggests deep reserves or active replenishment. If new molecules appear, that suggests subsurface layers exposed. Every data point refines the model. Formed beyond the carbon dioxide ice line in its parent protoplanetary disk. Ice is exposed to cosmic ray radiation over billions of years. Radiation processing can deplete water and concentrate carbon dioxide. The low water content could result from inhibited heat penetration. Carbon dioxide sublimes at lower temperature than water. The outer layers vent carbon dioxide. The water stays frozen underneath. The nickel without iron could be natural carbonyl chemistry near the nucleus. Exotic, but possible. The extreme polarization could be unusual dust grain size or composition. The ecliptic alignment could be sampling bias. We detect objects that pass through the inner solar system. Objects in the ecliptic plane are easier to find. The planetary flyby timing could be coincidence. The wow signal alignment could be coincidence. Multiply enough low probability events, and one will happen. That is the natural argument. The retrograde orbit allows multiple flybys. The solar conjunction timing hides activity during peak energy availability. The composition is optimized for stability. Carbon dioxide sublimates predictably. Water complicates thermal models. A probe designed for long interstellar transit would minimize volatiles that outgas in deep space. Carbon dioxide is stable, controllable. The nickel signature matches industrial refining. The wow signal aligns within search beam width. If you sent a probe, you would announce it. Radio transmission 48 years before arrival. Time for the signal to propagate. Time for recipients to prepare. The probe arrives, performs Oberth maneuver, deploys sub-probes toward Earth and other planets, uses solar gravity assist, maximum efficiency, minimum fuel. That is the artificial argument. JUICE will show post-perihelion activity. By Christmas 2025, we will know more. By March 2026, when it passes Jupiter, we will know enough. Nickel-enriched chemistry happens. Extreme polarization occurs. Alignment with the ecliptic is rare but possible. We learn that cometary diversity is greater than models predicted. We learn that other star systems produce objects chemically distinct from ours. We learn that the Milky Way's thick disk, where this originated 7 billion years ago or older, made comets differently than the solar system did 4.6 billion years ago. That is valuable. That reframes planetary formation theory. That tells you what happens in old low metallicity systems. If it is technological, it changes everything. Confirmed artificial interstellar object, proof of extraterrestrial engineering, proof of capability to cross light years, proof of intent to visit solar systems. The implications are not subtle. Whoever sent it can send more. The carbonyl process. Refining nickel implies industrial chemistry. Industry implies infrastructure. Infrastructure implies scale. Scale implies resources. Resources imply a civilization that has survived long enough to build and launch interstellar probes. The Fermi paradox collapses. The Great Filter is behind them, or ahead of us. If they are watching, they have been watching since at least 1977. If they are here now, hiding behind the sun, waiting to emerge, testing us. Black swan events have huge consequences. Pascal's wager applies. If the likelihood is small but the impact is existential, you prepare. IAW initiated a monitoring campaign. The Space Force tracks it, NASA tracks it, ESA tracks it. We have no intercept capability, no spacecraft ready. Comet Interceptor launches 2029. Too late for 3I Atlas. We could have intercepted it if we had started in July. We did not. If it releases probes, we track them passively. If they approach Earth, we track actively. If they land, we respond. Protocols exist. First contact scenarios. SETI post-detection guidelines. International frameworks. The United Nations Office for Outer Space Affairs. We have plans. We have never used them. Potentially transmitting. We will not know for 2 more weeks. November 11th, it reappears. November 27th, the IAWN campaign starts. December 19th, closest Earth approach. March 16th, 2026. Jupiter flyby, then exit. If we miss the November window, we lose the best data. If the high-rise images stay classified, we lose nucleus size. If no radio search happens, we lose transmission confirmation. If no one watches in November, we lose trajectory verification. Tom Statler, NASA's lead scientist for solar system small bodies, says it looks like a comet, acts like a comet, behaves like a comet. Natural body. Mainstream consensus. Avi Loeb says 30 to 40% likelihood of non-natural origin. Minority position. The data supports both. That is the problem. Every anomaly has a natural explanation and an artificial explanation. You cannot distinguish them without more evidence. The evidence comes in November. A timing that threads planets, a signal that preceded it by 48 years, 8 anomalies, rank 4. Cumulative probability 1 in 10 quadrillion, hidden behind the sun, emerging in 3 weeks. Either we are watching the most improbable natural object in recorded history, or we are watching first contact. November 4th, JUICE observes. November 11th, ground telescopes see it again. December 19th, closest to Earth. March 16th, 2026, closest to Jupiter. By then, we will have trajectory data, spectroscopy, radio searches, high-rise images, astrometry refined to meters. We will know if it maneuvered, we will know if it fragmented, we will know if it transmitted, we will know its size, we will know its composition changes, we will know if secondary objects exist. 3. I-Atlas, interstellar comet, carbon dioxide, rich nickel anomaly. Update formation models, publish papers. Wait for 4I. The Vera Rubin Observatory comes online. Legacy survey of space and time. 10-year survey. Detects millions of objects. Until 2025, astronomers found around 20,000 new asteroids per year. When Rubin began operations, it found 2,104 new asteroids in just 10 hours. The detection rate increased 100-fold. We will find more interstellar visitors, maybe 1 per year. Maybe more. Some will be stranger than 3 I-Atlas. Some will be normal. We will build statistics. We will understand the population. We will know if massive objects are common or if this one is unique. Europa Clipper spacecraft launched October 2024, currently in transit to Jupiter. Trajectory modeling shows potential line of sight to 3 I-Atlas during November 2025. Not a dedicated observation, not guaranteed, but possible. If pointing aligns, the ultraviolet spectrograph could detect gas emissions. The magnetometer could measure magnetic field perturbations if 3 I-Atlas carries charge or generates fields. The plasma instruments could sample the solar-wind interaction. Every asset matters. Every data point refines the model. Confirmed extraterrestrial technology. Origin unknown. Capabilities unknown. Intent unknown. We track it out of the solar system. We listen for transmissions. We scan for others. We build Comet Interceptor not for comets, but for probes. We prepare telescopes. We coordinate internationally. We establish protocols. We wait. Maybe it is a survey mission. Maybe it transmits back. Maybe more arrive. Maybe we are in a catalog now. Solar system Earth, third planet, oxygen, nitrogen, water, carbon-based life, radio-capable, nuclear-capable, flagged for follow-up. Maybe we just got noticed. 1977, radio pulse, 72 seconds. WOW, written in red ink, 2025. Interstellar object, 8 anomalies, hidden behind the sun. 48 years between signal and arrival. If they are connected, that is not a coincidence. That is a plan. That is a timetable. That is someone saying, we are coming and then coming. If they are not connected, we have two separate 1 in a million events happening in the same direction 48 years apart. Coincidence stacks on coincidence until coincidence stops being an explanation. Constellation Virgo, magnitude 10, rising before the sun. Aim your telescope, you will see a fuzzy star. That fuzzy star is either a lump of frozen carbon dioxide from another star system 7 billion years old outgassing naturally as it warms, or it is a machine. By Christmas, you will know which. The comet does not care what you think. The comet follows physics. Physics is measurement. Measurement is data. Data is truth. The truth arrives November 11th. We have waited since July. We can wait 3 more weeks. The universe has waited 7 billion years. It can wait 3 more weeks. The answer is coming. The answer is always coming. You just have to look. Then exit. Forever. One shot, no do-overs, no second chance. We watch, we measure, we learn. Natural or artificial, the data will decide. Not belief, not hope, not fear. Measurement. Outgassing at 150 kilograms per second. Velocity 68 kilometers per second. Ecliptic aligned. Retrograde. Carbon dioxide, rich. Nickel without iron. Extreme polarization. Sunward jet. Planetary flyby. Wow, signal aligned. Cumulative probability, 1 in 10 quadrillion. Either the most improbable natural object ever documented, or the first confirmed artificial interstellar probe. In 3 weeks, we find out. In 3 weeks, the comet clears the sun. In 3 weeks, telescopes lock on. In 3 weeks, the measurements start. In 3 weeks, the answer begins. You are here now. You are hearing this. You know the 8 anomalies. You know the timeline. You know what they are watching for. You know what it means if the trajectory changed. You know what it means if it stayed the same. You know we will know by Christmas. You know by March we will have Jupiter data. You know this is the moment, this is the window, this is the test. Truth does not care about comfort. Truth is what the data says when you force the universe to answer. November 11th, the universe answers. We just have to listen. We just have to look. We just have to measure. The rest is noise. In 3 weeks, you will see it. In 3 months, you will know what it did. In 5 months, you will know what it is. The countdown is running. The observations are scheduled. The instruments are ready. The scientists are ready. The data is coming. The answer is coming. The truth is coming. NASA coordinates assets. Hubble scheduled for ultraviolet spectroscopy in November. Webb scheduled for second NIR spec run in December. SphereX continues monitoring. TESS archives remain available for pre-discovery analysis. Swift Observatory stands ready for ultraviolet follow-up. Perseverance on Mars cannot observe directly. Wrong angle, wrong instruments. But Curiosity's mast cameras have wide field. Long shot, but possible. Parker Solar Probe is too far sunward. SOHO coronagraphs cannot resolve it. Punch mission not yet launched. Psyche and Lucy spacecraft are out of position. Juno is the next big opportunity. March 16th, 2026. Jupiter space. Then 3 Atlas exits. Leaves the inner solar system. Heads outward. Fades. Disappears. Gone forever. One chance. No return trajectory. No orbit. No comeback tour. Observe now or lose it.